With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so we are given with a question which says a glass hemisphere of refractive index 1.5 has a radius of curvature 16 cm. A small object O is located on its axis halfway between the plane and spherical surface. The distance between two images when viewed from the axis from the side of the hemisphere. So we need to calculate the distance between the two images formed due to this hemisphere and this plane surface. Alright, so first let's try to understand the refraction phenomena or the image formed due to the hemisphere surface. So we can write it over here as, so this can be the first case. Image distance after refraction from spherical surface. Alright, so after reflection from spherical surface we need to calculate the image distance. Alright, so let's try to draw or construct the ray diagram over here. So let's suppose that this is the tangent to this surface, and let's draw a normal over here. So from this normal, as we are going, the light ray will come over here and it will uh, go away from the normal. Alright, because we are moving from rarer from denser to rarer medium, so it will move away from the means normal. So this can be incident over somewhat over here. This can be considered to be coming from somewhere over here. Alright, so let's say this here the first image will be formed due to the refraction from spherical surface. So we need to calculate the distance. Let's suppose that this point, that is pole point, is A. So we are interested in finding the distance AI first. So this is the refraction to the spherical surface, so we will use the formula mu2 by V minus of mu1 by U, and that is equals to mu2 minus mu1 upon R. So mu2 is that refractive index of the medium from to where the light goes after refraction. So here it is R, so refractive index will be 1 over here. So we can write it as 1 divided by V. V is the image distance, that is we need to calculate, so we will keep it as it is, minus of mu 1. Mu1 is nothing but from where the light is coming, that is from the spherical surface or from the glass hemisphere, and it is having a refractive index 1.5, so we will write 1.5 divided by U, that is the object distance. So object distance, the incident light is towards left and object distance is measured in the rightward direction, so it will be taken as negative, and it is halfway, that is A to B distance is 16, so halfway means it will be 8, and it will be minus 8, and that is equals to mu2, that is 1 minus of 1.5 divided by R has been given as 16 centimeters. So solving this further, we can say the value of 1 by V can be written as it can be given as, again if we carefully analyze, the radius is measured from the pole towards this distance, so it will be again negative. Alright, so we have to be careful with this. As we can see, the incident light is in this direction, so this direction will be considered as positive, but every distance is measured from the pole for the spherical case, so we are measuring it in the rightward direction, so it has to be negative over here. So we can say this will become 1.5, that is it can be written as 1 by 32, and here it will become minus of 1.5 divided by 8. Alright, so solving this value, we can get the answer as this can be written as 1 by 32. If we take the LCM, so this can be we can get the answer as minus 5 by 32, that is 1 by V, or we can say the value of V comes out to be minus 32 by 5. Alright, since we are getting the value as negative, So the image is formed towards the left. The negative sign is showing that image is formed towards the left of the object, that is towards this side, as we can see it over here. So we can write, uh, if we in terms of magnitude, it can be written as the value of v is nothing but it is ai1. All right, and it can be given as 6.4. all right, so we can write it as 6.4 centimeter. So let's keep this equation as 1. Or so we have calculated the value of ai. Now we can go for the next case, that is refraction from the plane surface. So if we try to construct the diagram, so let's suppose that this is the normal and we can take a ray over here. Again it will be bent away from the normal, so this can be over something over here. We can get the image. So we something over here, let's say this is our I2 image that has been formed over here. So we are interested in finding the value of bi2 over here. So we can say for the second case we can write refraction from plane surface. So plane surface refraction. So this can be written as, again we will use the formula mu2 by v minus of mu1 by u, and that is equals to mu2 minus mu1 divided by r. For plane surface the value of r is infinity, so we can write mu2 by v, and that is equals to mu1 by u, and here we will give for plane surface r equals to infinity for plane surface. All right, surface. So from here we can get the value of v. V can be written as mu2 by mu1 into u. So we can see mu2 is from where the ray will go after refraction, that is this will become mu2 now, and here it will be mu1. So mu2 can be written as 1. So 1 by 1.5, 1 by 1.5 into u. U is, as we can see, the ray direction for this case is towards this. So the plane surface convention doesn't play an important role. Why? Because we can see the sign of v and u should be same. All right, why? Because we can see it is mathematically both the quantities are equal, so their sign has to be equal. All right, so here the convention is of least importance, so we will directly use the value. U can be written as 8, so it comes out to be 8 by 1.5. So this is the value of v we have got, and v is nothing but here it is bi2, we can say the distance bi2, and let's say suppose that this is our equation number 2. So we are interested in finding the distance between i1 and i2. So we can write i1 i2 can be written as, now we can say the distance i1 i2 can be given as ab minus of ai1 minus of bi2. If we substitute the value, we can say ab is 16 minus ai can be written as 32 by 5 minus of bi2 can be written as 8 by 15, and this can be written as 48 by 5 minus of 8 by 15, 80 by 15, sorry. So if you multiply and divide by if you multiply both the term by 3, so we can write it as this can be written as 144 divided by 15 minus of 80 by 15, and that gives us the value as 64 by 15 centimeter. All right, so this is the answer to this question, which is matching with option C. I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.